Space is becoming increasingly crowded. Space debris, remnants of past missions, moves at incredible speeds and poses a serious threat to satellites and future missions. Without functioning satellites, modern communication, navigation and weather forecasting would be severely limited. A potential technical approach is currently being explored with OMLET. OMLET stands for Orbit Maintenance via Laser Momentum Transfer. The European Space Agency project is being developed by a team of international partners led by the Institute of Technical Physics of the German Aerospace Center.
We want to design a ground-based station that is capable of launching a high-power laser into low Earth orbit in order to change the orbit of space debris objects enough in order to avoid collisions.
By precisely directing a powerful laser beam, the object is slightly decelerated, allowing it to safely change its trajectory in order to avoid a high-risk close approach with another satellite or debris. In its technical design, many different subsystems such as the laser, adaptive optics, telescope, search and guidance, control software, as well as safety systems need to be brought together to make the OMLET machine work. One of the key components of the engineering station is the laser. At Trumpf Scientific Lasers in Germany, scientists and engineers design a novel laser system to meet the challenging power and beam quality demands for laser momentum transfer.
In order to have an effective push on the space debris, the first simulation showed we need something in the range of 50 kilowatts. So this is really a tremendous amount of power. And we plan to do this by combining multiple lower power units and basically merge the output beam into a single output.
At High Lays in the Czech Republic, tests are conducted to determine how different materials react to laser beams. However, there are challenges. The Earth's atmosphere distorts laser beams, making precise targeting difficult. A sophisticated adaptive optics system is needed to compensate for these distortions.
It's a technology which is well known in astronomy, where you correct images of galaxies and other celestial objects by means of a laser guide star. But it has never been done for the other way around, so sending a light signal from the ground up to space. So it's a new concept we are working on.
The vision of OMLET, a global network of stations that identify debris, track their orbits and prevent collisions.
I'd like to develop a laser that can help globally keeping the space tidy and supporting future space mission by avoiding collisions.
OMLET is a really exciting project. We are at the forefront of research and development in order to help make space more sustainable, making operations easier and save money and save time.